So, in terms of agenda, first I want to talk a little bit about the API structure in terms of JDK 9, because what we're talking about here is primarily modularization of the JDK, but also modularization of applications. So the first thing that we need to talk about is how the APIs work within JDK 9, because there are some reasonable changes there. And these are some of the things which are going to affect people as they move from JDK 8 to JDK 9. Then we'll talk a bit about Jigsaw and modules. There's probably some stuff there that I can move over fairly rapidly because Alex has already covered some of the basics of what modules are and some of the issues there. And then I'll talk a bit about actually developing code with the module system in JDK 9. So how you actually use the module system both for the JDK modules and then also the modules that you're going to create for your application. And then we've got some summary and further information, places to go. So let's start then with the structure of the JDK 9 APIs. The first thing about this is what were the goals for Project Jigsaw? Now, clearly, Project Jigsaw is one of these things that has been around for some time. And in fact, it's always fun to listen to Mark Reinhold present when he talks about Jigsaw, because he kind of accepts that he's been working on this for a while. And so when he did the keynote at DevOps last year, he stood up and he said, we've been working on Jigsaw for some time, which is one of those kind of like, yes, we have been working on it for some time. It's quite an understatement. It's about 8 years now. So even though modularity has been around for nearly 18 years, as Alex said, about 8 of those have been Project Jigsaw. So the goals are primarily to make Java SE more scalable and more flexible. Because if you go back to in the history of JDK, and Steve, who's sitting at the front here, knows very much about this. If you look back in the history of JDK, back in 1.0, there were about 200 classes in the class files. So rt.jar had about 200 classes in it. And I like to say that in JDK 1.0, you could actually hold all of the class files and the method definitions in your head. As we've gone through time, we've added more and more APIs to the class libraries, which is the logical thing to do because it means you don't have to write things like a list class. You don't have to write things like JDBC classes. All that kind of stuff is done for you. So we now have a much richer set of APIs, but there's about 4,000 classes in rt.jar now, which means that it's kind of grown and grown and grown into this like big amorphous lump. And no program is going to use all 4,000 of those classes, which means that we really need to break it up into more manageable chunks so that we can say, well, okay, I'm going to use SQL, I'm going to use AWT, I'm going to use util, whatever, but I don't need Corba, for example. Very few people need Corba, so it's one of those things that we can easily kind of push off to the side and allow to gather dust. So it's about making it more scalable, about making it more flexible. What this also sort of brings in as some advantages is the fact that it allows us to make the JDK more maintainable, it allows your applications to become more maintainable, better in terms of performance because, startup time is improved because you're not trying to load all these 4,000 classes as you start up your application. You only need to load up the classes that you actually require. Improve security because the way that the designers of Jigsaw like to talk about this is reducing the attack surface, which is a lovely way of explaining how it makes it more secure. Less opportunity for people to find ways through the security if there's less pieces of code to attack. So it's as simple as that. And then the third thing is, in terms of your applications, is simplifying construction, simplifying deployment, simplifying maintenance of large-scale applications. And these kind of big web applications that we work on. Now, as an employee of Azure now, rather than an employee of Oracle, it does allow me to be a smartass, which means that I can also now add a fourth goal for Project Jigsaw, which is really to see how long people can keep the project going for before people get tired of it. So Jigsaw is actually proposed for JDK 9. It's not actually guaranteed. It is proposed for inclusion in JDK 9. because the specification for Java SE 9 hasn't come out yet, so we're still waiting to see. Right, so now let's talk about classification of APIs, because this is quite important. Now, if you look at rt.jar, like I say, there's like 4,000 odd classes in there. But there's classes in there which are both public, because they're part of the Java SE specification, and there's some classes in there which are not part of the Java SE specification, but are kind of designed to be publicly accessible, because I'm going to say we a lot, even though I don't really mean it, because I'm kind of talking when I used to work for Oracle. Even though they're designed to be publicly available. So there's things like some of the com.sun APIs. There's some of the things like, I'm trying to think which ones are the com.sun. Oh, some of the XML processing. There's some stuff in there. Some of the Apache stuff is in com.sun, bizarrely. And there's also some JDK APIs, primarily around things like NASTorn. So if you want to use JavaScript as part of the API, because that's not defined in Java SE, it comes through the JDK APIs. So these are intended for public use. But then there's also a whole bunch of APIs which are in rt.jar because they need to be there, but they're not designed for public use. So there's these sun.star APIs. And of course the most famous of or infamous of these is the good old sun.misc.unsafe. I think it's just a wonderful name for a class, isn't it? Unsafe. It just sums up exactly what it is. So these are the two kind of types of APIs that we've got. Now, in terms of compatibility, this is a big thing for Java. Always has been a big thing for Java, is the idea of maintaining backwards compatibility. Oracle and Sun before them have always been very concerned about not breaking existing code. And the way I like to explain it is there's nothing worse than taking code which compiles and works and having to modify it to make it compile and work, because it already does that. So you're just wasting your time doing that. So the idea is that if an application uses only the supported APIs of a particular version N of Java, then it should work on version N+1, even without recompilation. That's clearly something which doesn't always work, because if you look at some of the changes that have been made through history in Java, various things have been introduced which have broken backwards compatibility. Examples are in JDK 1.4, the introduction of assertions. So assert became a reserved word, which meant you couldn't use it as a variable name. In JDK 5, we had the introduction of enumerations. Again, this introduced a new reserved word in Java, which meant that you had to potentially recompile code. I remember talking about JDK 5 many years ago and saying to people, well, this is not really a problem, is it? Because, of course, we use very expressive variable names, so nobody would use enum as a variable name. So then I went and recompiled some of my own code and found that I had used enum as a variable name. But anyway, so most of the time, it's very important that if you use the standard APIs, it will work on the next version without any problems. In terms of Java, there have been, there is built into the specification, built into the sort of standardization, the fact that Oracle and Sun said that we could remove APIs, but only with advance notice. So the idea was we wouldn't just take them away, they would be removed at some point, but you would have to be told about it ahead of time. And if you look at what's actually been deprecated to date, since 1.1, which was when deprecation was first introduced, there are 23 classes, 18 interfaces, and 379 methods that have been deprecated, and to date, not one of those has actually been removed. So deprecation is one of those interesting things in Java. Now, JDK 9 is actually going to introduce a number of incompatible changes. These are not incompatible changes primarily around language and around APIs. Some of it is kind of related to APIs, but it's not like introducing new reserved words. It's not that kind of breaking of compatibility. So the first thing is there's going to be some encapsulation of some of the internal APIs. I'm going to talk more about that in a moment in a bit more detail, but some of the internal APIs will be encapsulated in the new module system, which means that you will no longer be able to use them with your application code. Although, like I say, I'll talk more about that in a moment because there are ways around that. There will be a very small number of supported APIs that are going to be removed. There's actually 6. I don't know why they've actually decided on 6 particular APIs, but they are all either add or remove property change listener. There's 4 in the Pack 200 class, and there's 2 in log manager. 6 of them need to be removed. Presumably that's because of links between different modules within or different classes within the system, which just make it too hard to break up everything, so they are being removed. There will be a change to the binary structure of the Java runtime and the JDK. And I'll talk a little bit more about that in a moment as well. 3 things which are also going to be changed which will affect compatibility. I'm not going to talk about these in more detail because I don't have enough time in this presentation. One is the removal of the endorsed standards override and extensions mechanism. It took me a while to figure out what that actually meant, but it's really around things like app servers. So app servers have the ability to kind of replace or extend the standard APIs. So that is actually going to be removed from JDK 9. There are various things that the app server vendors will do to allow them to work around this, but it's one of the things that's being changed in Java JDK 9. There is a new version string format that's been introduced, and that comes back to what Alex was saying about simplifying the way that we define the versioning of Java. So that's going to be a potentially incompatible change, because if you rely on version strings for the JDK or the JRE, and you're testing against that, then you may have to change your code to make it work with JDK 9. And then one very minor thing, which is that a single underscore will no longer be allowed as an identifier in source code. So it's already been removed from Lambda expressions, but it's going to be removed completely from the Java language. That's kind of like a sort of a change. Just anybody use a single underscore as a variable name? Yes, of course. So probably not going to be too widespread in terms of its effect. Now, if we look at unsupported API usage, this is always a kind of interesting thing. Now, I don't know if you can read down at the bottom there, but essentially what Oracle did was they did some analysis, and they basically took a whole bunch of code, which is like, their middleware, Fusion stuff, and they analyzed it to find out which were the most popular unsupported APIs that Oracle used internally. So I'm only going to go through the top 3. Anybody want to guess what number 1 was? Yes, I did.
Base 64.
Oh, well done, Steve. You must. Yes, Base 64 encoder was actually the most popular unsupported API that was used internally in Oracle's code. Anybody want to guess what number 2 is? And you don't get to answer this time.
Unsafe.
Unsafe, yes. And anybody want to guess what number 3 was? It was actually Base 64 decoder. So it's just interesting to see, there's a whole bunch of other ones that were used as well, but these were the most popular 3 that were used. The thing about this is that it indicates that there is a lot of use of unsupported, in effect, private APIs within code, even Oracle's internal code, which has a big impact. So how do Oracle go about changing things, not exposing these private APIs without breaking a lot of code? And in order to do that, what they've done is they've basically divided it into 2 parts. There's what's called non-critical internal APIs and critical internal APIs. Non-critical ones are ones that either have a pretty much sort of no use outside of the JDK. They're very specific. Nobody would really use them in an application because they just don't have any use in an application. They're only really for the JDK. And then there's ones which are only used for convenience, where alternatives exist. So the Base 64 encode and decode is a good example of that. JDK 8, we actually introduced a util package that was specifically giving you base 64 encoding and decoding. The fact that it took was like 18 years to get to having a base 64 encode and decode API is one of those sort of bizarre things. But in that case, there are some alternatives, so we don't need to worry about those quite so much. But then there's also these critical ones where you've got functionality which would be difficult, if not impossible, to implement outside the JDK. And that's things like unsafe, because it just has the kind of functionality which you can't really replicate outside of the JDK because of the interaction with the memory system and so on. So there is a JEP, which is a JDK enhancement proposal, number 260, which is about how these APIs are going to be handled in terms of the module system from the point of view of what is actually done with them. So the first thing is that all non-critical JDK internal APIs will be encapsulated, which means that all of the ones which are things that either have no real use or have an alternative outside of the internal APIs will be encapsulated, so they'll no longer be publicly accessible from application code. Number two is that all critical JDK APIs for which there is some kind of supported replacement in JDK 8, those will be encapsulated as well. So if there is something like base 64 encode and decode, then those will be encapsulated as well. So those won't be publicly accessible. And then the third thing is that they're not going to encapsulate any other critical APIs. This is quite a big decision that was made a while ago, because originally they were going to encapsulate all of these APIs. So unsafe was going to be encapsulated, nobody would be able to access it, and that was going to cause all sorts of problems. So there was a bit of backtracking done, and the decision was made that they weren't going to encapsulate those particular APIs. They were critical, there wasn't a replacement for them, but in JDK 9 they would be deprecated, which means that we're giving notice, they are giving notice that after JDK 9 they will go away. Plan is in JDK 10 either to encapsulate or to remove them, whichever makes most sense, but to provide some sort of alternative. So because unsafe is one of those things that a lot of people have used, because it has functionality that people actually do require, the idea is that in JDK 10 there will be a replacement for unsafe, which will be a publicly available API that will be supported. Now, how that's going to work, we don't know yet. Various people are working on it, but there's ideas about how to do that. The other thing that's going to be available is a command line option, so that for the encapsulated APIs, the ones that you won't be able to publicly access, if you really do want those, so if you really determine that you want access to those, in JDK 9 there'll be a command line option that will allow you to turn those on and make them publicly available within your code. So you do have a kind of override which will allow you to have backwards compatibility. But the idea is that you shouldn't really be using those at all, so you shouldn't have to use that, but if you really, really have to, then you can. Now, in terms of the binary structure of the JDK and the JRE, this is, as I said, a potentially disruptive change, because it will change a lot of the way that things look in terms of the JDK. This again is covered by JDK enhancement proposal number 220, and what we're really doing is changing the distinction between having a separate JDK and a separate JRE, so that really we're just going to have one thing, which is a kind of JDK JRE. They have been doing this for quite a while now, so the idea is that the layout for it has been publicly available for a while. People have been able to see it, they have been able to get used to the idea. If we look at the structure of the JDK as it is before JDK 9, this is what we see. So there's a JDK directory. Within that, you've got a bin directory which has Java-C. It has a variety of other tools in there. There's a lib directory which has things like the tools.jar file in it. And then there's a JRE subdirectory which then has a bin and a lib directory in it as well. So the lib directory in the JRE has rt.jar, also has a whole load of native libraries. The bin directory has Java and various other things like keytool and some of the time loading applications, stuff like that. All the things that are in the JRE bin are also in the JDK bin. So there's two sets of everything that's in the JRE bin. What that's going to look like in JDK 9 is a little bit flatter, a little bit simpler. So you're going to have one bin directory which will have Java in it, will have Java-C in it, and so on. There's now going to be a separate conf directory because in JDK before that there wasn't any single place where any configuration files went. This is a bit problematic because it didn't allow the JDK people to separate out these files, so it was obvious which files could be touched by people deploying the JDK versus files that shouldn't be touched. So now there's a conf directory where you will know that these are files which you may touch. Other ones, leave them alone. And then there'll be a lib directory. There will be no longer a JRE directory separately. There will no longer be a tools.jar file. There will no longer be an rt.jar file. So things like this are big changes. Tools.jar, rt.jar, because we're moving to a module system, that's why there won't be one monolithic jar file. So the second part, let's talk about Jigsaw, let's talk about modules. Now, in terms of Jigsaw's modules, the fundamentals of this is it essentially, as Alex already explained, what we're really talking about here is grouping things together, grouping code together. And in terms of Java, what we're talking about here is a collection of packages. But a module, in terms of Jigsaw, can contain other things as well. So if you want to, you can put native code in there. If you need libraries, those can go in a module. If you need resource files, images, text, whatever, that can go in there as well. And configuration data can all go in your module. So we end up with a module which has a name, in this case com.azul.zoop, and it has a number of packages in it which are available and we can include and make use of. Now, how we go about actually creating a module is reasonably simple. So we take the Java files that we have for the individual parts of our package, and then we need to add to that a module info.java file. That can be compiled in exactly the same way, so we just treat it as if it's a Java file. Compiled becomes a class file along with all the class files for the individual classes that we have within our package, within our module, and that becomes a module. In terms of the definition of the module info.java file, it's, well, basically you've got module, and then you've got the name of the module, and then you've got a set of braces within which there are definitions of things relating to that module itself. It's interesting with the way that this has been done, because what you might think is, oh, hang on, now we've got module in there. Now, if we're going to compile that, does that mean that module is now going to become a reserved word in Java? Which means that that's going to break all sorts of backwards compatibility, because I'm sure many people do use module as a variable name. Well, no, that's not actually happening. I can't find any evidence to support the fact that module is going to become a reserved word in JDK 9, so we don't need to worry about that. I think it is that they're just compiling that in a special way because it is a module info.java file, and they're not treating it as something. They're treating it as a Java file, but not really as a true Java file. It's kind of special Java file. Then we get into the dependencies. So again, Alex already kind of covered some of the basic ideas here. But essentially what we're saying is that we have a module here called Zoop, and that depends on things in the module Zeta. So we have a dependency between the two, and in terms of how we define our module Zoop, we say, okay, it's module, it's got a name, which is Zoop, and then we say it requires the module Zeta. So we give it requires. Again, requires is not going to become a reserved word in Java, so we don't have to worry about that. But it tells us what module we're creating and what the dependencies are. Then if we look at, let's say we have an application, that may have a dependency on Zoop, and it may also have a dependency on one of the modules from the JDK. So what we're going to do is we're going to say, okay, that also depends on java.sql. So in addition to requiring Zoop, it also requires java.sql. So we just list out the dependencies. What that then allows us to do is to construct a dependency graph. So we can say that our app depends on java.sql. It also depends on Zoop. Zoop has a dependency itself on Zeta, but because app doesn't depend directly on Zeta, it won't be able to see that. And then everything depends on java.base. You can think of java.base as kind of like the object in terms of the class hierarchy. Everything basically depends on java.base, and that's the sort of like the bottom of the dependency. But then obviously there's going to be other dependencies within that. So if you look at java.sql, there's a dependency between java.sql and java.xml and java.logging, and of course those both, because everything depends on java.base, those will have dependencies on java.base as well. So we can build up the module dependency graph of our application, and we can see all of the individual dependencies. But then we also need to have the other way. So what are we actually exposing from a module that other modules that depend on it can see? So in addition to defining what a module requires, we can also say what a module exports. Here, what we're saying is that in the case of Zoop, we've got 3 packages in there. We've got alpha, beta, and theta, but only alpha and beta are going to be publicly accessible. So if something depends on Zoop, it will only be able to access packages alpha and beta. Even though theta is in that module, because it's not exported, it won't be visible to the modules that depend on it, so it won't be able to use it. So we need to understand, in terms of accessibility of a particular package within a module, for it to be used, 2 things have to be true. First is that the package must be exported by the containing module. So we have to make sure that it's exported so that it's visible to modules that have a dependency on it. And then the containing module must also be read by the module that requires it. So the module that's going to read it has to have a dependency on it. So we have this 2-way link. It has to export it, and then we have to depend on it in order to read the packages within that. Once we have those 2 things, any public types from those packages can be used. But then we come into an issue which is readability versus dependency. So in the case we've got here, we've got our app, which depends on java.sql, and that depends on java.logging. And in terms of the code, in our app, we might have something where we create a reference to a driver for SQL, and then from that, we're getting access to a logger, and we want to log something. But the problem we have is that java.sql obviously has a dependency on logging, but the app doesn't have a dependency on logging. Now remember that in order to see a particular package, you have to both export it from the package from the module. So logging will export the logging package, but we also have to read it. So we don't currently have a dependency between app and logging because it's an indirect dependency. To get around that, what we can do is we can re-export, in effect, or re-export the packages that are used by another module. So in this case, module java.sql requires java.logging, but it also then says requires public java.logging. That then says that for that particular module, it will export all of the publicly available packages within java.logging. So we don't have to create an explicit link between app and java.logging because java.sql is re-exporting the packages that are made public by logging. That way we can use them without any problem. So it's a way of allowing the not having to remember to put all of the dependencies, even though they're not obvious dependencies, because we'd have to check whether Java SQL depends on logging and so on. So we get around that problem. So then what we could do is look at our dependency graph and actually create a readability graph. So Java.SQL, we know depends on XML and logging, but now we have, because these are re-exporting through the public keyword, the module, the packages within XML, within logging, so now we have readability within our app of the public packages in those modules. Which kind of brings us to accessibility in Java. Now this is what we're used to in terms of Java. We have different levels of accessibility. Public, as we know, this makes it available to anybody who can see our class or see our package. We have protected, which means it's only accessible within the subclasses of that class. We have package accessibility, so we don't put anything there, then it's accessible within other classes of the same package. And we have private, which means it's only accessible within the class itself. That's changing in JDK 9. And this is quite a substantial change, because even though we're not changing public, the keyword, and we're not changing the way that we actually define anything, you can still define a public method, you can still define public variables. How those things are accessible to other classes does change. So now we have public to everyone, but we also have, in certain cases, public, but only to specific modules, because we're exporting them, so it's only certain modules that will see that. And then we have only public within a module, because we're not exporting those packages, and therefore the public elements of those packages will not be visible outside of the module. So that is quite a change, because now public does not mean accessible in the same way that it did before JDK 9. Like I say, it's not a change in terms of the language itself, but it is a change in terms of understanding how different classes relate to one another, and how you can actually see different elements within that, so different methods, different variables. And then, I know this diagram is probably rather difficult to see, because I was going to redo the diagram, but I looked at how complicated it was, and I thought, no, I'll just do a screen capture from the slide that I think it was Alan Bateman used at DevOps last year, so I just screen capped it. But it shows you the essential breakdown of the modules in JDK 9. It has been really quite simplified in terms of all the different modules that have, and as we heard earlier on, as Alex was saying, we had this weird sort of dependencies between things. So you ended up with, AWT or beans depending on AWT, which was a really weird kind of thing. And it was interesting to hear the explanation of why that happened. But those kinds of things had to be broken in order to allow the dividing up of the module system within the JDK to make it a much cleaner kind of thing. Because otherwise, if you follow all those links and you end up with beans depending on AWT and all that sort of stuff, you go back to the idea of just having like 3 big modules maybe. So let's talk a little bit about how we can develop code using Jigsaw with the module system. So simplest thing is if we want to create a single module. So we've got a module here, and we're going to have one particular Java file. So we're just going to use Java C, we're going to compile it, we're going to say where we want it to go, which is the mods directory, and we're going to provide a moduleinfo.java file for that, and the Java file for the actual class itself. That gets compiled, we end up with 2 class files in our mods directory. Nothing terribly exciting about that. We also have now the idea of a module path, which doesn't replace, it augments the class path. So we've gone through class path hell, and rather than getting rid of class path, we've just added more things to it. So now we have module path as well. So you've got two paths to think about. So module path, basically same idea. You can have a sequence of directories which contain different modules, and those will be searched in order to find the modules that you need in order to compile your code. So then we can say, okay, let's compile our code. We'll use the module path, in this case mlib, and we'll compile it into the mods directory again. This time, if there's dependencies between that and other modules, those will be resolved by looking in the module path and finding the modules which are there, and then figuring out what the dependencies are, because we know that in the module info.java file, it says what the dependencies are, so the compiler can then check those and grab what's needed and compile it in. So we end up with the same essential thing. We've got our class files, and they are resolved based on the modules. If we want to execute our application, there's a number of different ways of doing this. I don't have time to go through. There's a lot of other slides I had for this presentation, for a longer version. But this is kind of like the simplest way if you're just using a module path. So you do Java, specify the module path of where the modules are. Then you say that the module you want to execute, in this case, is com.azul.app. And then you specify what the main class is within that. So com.azul.app.main. That then runs, says, okay, our application is running. And if we want to, they've allowed module path, in the same way the class path can be abbreviated to CP, then you can abbreviate module path to MP. Now, when it comes to packaging, we can package with modular jars. So what we do in this case is we include the module info.class file into our jar file. So it's no different to jar files that we had before, except that it's got a module info.class file. In order to create that, we just do the jar command, same kind of idea as before, jar ---- create, ---- file to say which jar we're going to actually create. Give it the main class as being com.azul.app.main, and say that the mods, where we're getting the mods from, and compile it in from the stuff that's in the current directory. What we can then do is we can look at the module information for that particular jar file. So if you do jar ---- file app.jar and then do -p, you'll get some nice information about what is actually in there and what the dependencies are. So it'll say that the name of this module is com.azul.app. It requires Zoop, it requires base, that's mandated, requires SQL, and then the main class is com.azul.app.main. All very straightforward. Then, if we want to execute from the jar file, we can just do java -mp from module path, say where the modules are. So we've got mylib for, actually it should be mlib, for where the modules that we've created are, mods for the existing modules, and then the main is com.azul.app.main. So we can just, everything runs, and we get our application again. The other thing that's been done is to provide the ability to link. So we're familiar in native code of being able to link applications. So that's when you take all your libraries, you resolve everything, and you create a single executable. So what linking allows you to do in JDK 9 is to take all the modules that you have and build a runtime of your application. So in this case, what we can do is we can say JLink -module path JDK mods. So that's where the JDK module files are. So it'll point to the JDK lib directory. Add the mods, which is in this case we're just going to add one, which is java.base, and output into my image. And then if you take my image, which will the JLink will actually create a modular runtime image. So this in essence, creates a JDK or JRE for you. So a complete bundle of the Java runtime, which is required to run your application. And then if you run the Java, which is in the bin, and you do -list mods, you'll get one module, which is java.base, and because that's the only one that we've actually put in there. And it will give you the version number of that module, which is 9.0, because it's JDK 9. We can then extend that, and we can say, okay, well, for our application, what we want to do is we want to say, okay, link using the module path where we've got JDK mods and we've got my mods, and then we're going to add the module com.azul.app and output into my image. Now, because the app is already a module, it already has the information about what the dependencies are and what the main class is. So if we do list mods, we'll see java.base, java.logging, java.sql, java.xml, which are all the standard JDK modules that we need with version numbers, and we'll get com.azul.app, Zoop, and Zeta, which are the app itself, and then the two modules that it depends on, or the Zoop module that it depends on, which then in turn depends on Zeta, and we'll have a version number of 1.0 with those as well. So that is really kind of the basics of Jigsaw. I had more slides, but given I only have 45 minutes, I don't have time to go through the rest of those. So I'm kind of going to stop there. There's a lot more detail about Jigsaw in terms of taking it to the next level, saying, okay, if you've got existing jar files, if you've got an existing application, how do you go about modularizing it? Because one of the things that you can do is you can take an existing jar file and you can create it, or you can turn it into an automatic module. So what that essentially does is allow it to export all of the classes, all of the packages which are publicly accessible. So you don't have to do anything to it. You can just say, right, this is just a jar file. Treat it like it was a module where everything is public. So it exports everything that's within the jar file. And that way you can start bringing that in. And so there's two different approaches you can take. You can take the bottom-up approach where you change your code and actually redo your library code, or you can take the top-down approach where you start building all the modules for your application, splitting everything up, and doing it that way. So, like I say, unfortunately, there is more information about that. Maybe I can come back and do another presentation at a later date where we can cover that in a bit more detail. So to summarize this bit of the presentation, modularization is a big change for Java. It's not just a change in terms of splitting up the class files and the rt.jar into a bunch of modules. There's a lot more to it than that in terms of the structure of the APIs. Like I say, things like encapsulation of the private APIs, things like Mr. Unsafe, base64 encoder, and so on, is going to have an impact on application code. The fact that public access doesn't really mean public anymore. Depends on whether you export the particular package, depends on whether you require a particular package, and so on. You do have a lot of flexibility in terms of defining what is exported versus what is not. The new linking capability allows you to build a runtime image. And again, there's a bit, you can take it a bit further. Once you have modules for everything, you can actually get to the point where you can generate the kind of something that we've always wanted from Java, which is a single command line to run. So you can just basically say, my app, which is in the bin directory of your runtime image, and off it goes, and it runs your application. So it was one of the things that I always found most frustrating about Java was you could never just run your app. You had to do Java minus class path, blah, 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 and do, find the main direct and specify everything. So now you got to the point where you can actually just do my app, and it runs. There's a lot more to learning about modularizing existing code, as I said. Maybe we can go through that at another point. But it will make applications simpler to deploy, simpler to manage. So, yeah, that's that. Place to go for more information, openjdk.java.net. There's also the JEPs. There's 5 JEPs in particular that relate specifically to Jigsaw and the API structure. So there's 200, 201, 220, 260, 261. Project Jigsaw, which is sub-project within JDK.net, or OpenJDK, and JSR 376, which is the JSR for Project Jigsaw. And then, because I am now an employee of Azul, I will actually put a couple of links there. One is Zulu.org, which is the build that Azul are doing of the OpenJDK. So it's a binary distribution based purely on the OpenJDK source code. It is free. We support JDK 6, 7, 8, and 9. Right now, we don't, having just done a presentation all about Jigsaw, our build doesn't support Jigsaw. because Jigsaw is currently, if you look at the Open JDK projects, there's JDK 9 is one build from Open JDK, that's the main build. But then there's another kind of sub build, which is the Jigsaw build that has all the tooling and everything in that. At some point they will merge the Jigsaw build back into the main tree, and at that point we certainly will pick it up. I've been talking to our product management about getting a specific build of Jigsaw done, but we're not quite got to that point as well. And of course, we also have Zing, which is our JVM for low latency. So if anybody's interested in low latency, come and talk to me later. So I've now done my marketing bit. And that's it. So questions?
You talked about scalability as one of the factors. I presume that's scaling down. I think you did a tutorial on the Freescale K64F, and that managed to run on an embedded system with a footprint below a meg. How realistically, how small, if I don't want sort of all the XML guff, how small can I get a JDK runtime?
Right. That is absolutely correct. The idea of scalability is scaling down. So we can target Java SE at smaller devices. If you look at the compact profiles from JDK 8, which are reasonably good sort of keys as to like what you can do with the module system, even though the module system gives you finer grained ways of configuring. The smallest profile 1, was 10.4 megs. You could probably strip it down a bit more than that, because that did include some logging. It did I'm not sure if it did include some XML. I think it was just logging in there. But if you didn't need logging, if you just needed base, I haven't looked at the size of the base module, but I'm guessing. Steve, do you know how? No. I'm guessing it's under 10 megs for the libraries and runtime. So you can squeeze it down into quite a small space.
Any other questions over here?
Hello, testing. The change semantics of public seem to be quite dangerous in terms of how would a dependency injection framework work if it's not able to access the public classes like beans, for example, from within a module? Well, I suppose the answer to that is that the dependency injection will still work so long as you have visibility of the necessary packages and therefore the classes within those packages. That will be something which is one of the things that you need to do in terms of migrating from JDK 8 and earlier to JDK 9, is to make sure that you have the right dependencies from whatever packages being used to the ones which are going to get injected. So it's essentially figuring out what those dependencies are and then putting them into your package or your module structure. So yeah, I mean, that's why I say it is something which does affect compatibility and does require work from the point of view of but that implies you have to export your implementation classes, and wouldn't those be ideal candidates for things to be hidden within a module? Well, not if you want to use them. I mean, you need to export those implementation classes because it's the whole idea of having boundaries. So unless you export it, it's not going to be visible. So it's kind of that idea of switching to having, rather than everything being available, to only having the things that you export. So it's a kind of it's just basically a big change. I think the problem is that you don't normally want application code to have direct implementation dependencies to other modules. You may want to give that kind of privilege, that kind of special privilege, to a management agent like the Spring framework, for example, if you're using Spring. Right. And there is an example of a privileged access. Sorry. Thinking about it, you could still do it because you can in effect export public the packet. Well, I suppose that's still exporting it. So there is this magic class which is allowed to do this, one magic sort of management agent, which is the service loader. Right. But the service loader is so restricted in functionality that I don't see it ever being a particularly functional replacement for the dependency injection frameworks that people are using. So I think this is actually one of the biggest issues that's going on in the expert group and caused the delay.
Yes.
So I think that's a problem that needs to be solved.
Yeah, I think certainly when it comes to JDK 9 and then Java EE, there's going to be a lot of discussion about how best to address the needs of both. Yeah.
Thank you.
Sorry, I don't have a better answer for that.
Hi. Sorry if this is a slightly basic question, but I'm presuming that an export and import of a package implies exporting and importing all of its sub-packages.
No.
Is that a no?
Right, yeah, because you would do an export of a package. But, yeah, because who said there's no such thing as a sub-package? Yeah. Yes, yeah. Yeah. So,
okay.
Yeah, because basically if you did like export com.foo, that would export com.foo. But if you wanted to export com.foo.bar, that would have to be a separate export. You wouldn't automatically get com.foo.bar if you export com.foo because it's a separate package. So even though it's a sub-package in naming, it's not a sub-package from the point of view of visibility.
So the JLink tool that you talked about sounds interesting. Does that copy the modules over as separate files, or does it concatenate them into one big file?
Separate files. As far as I
So
know,
if you wanted to look at the file system and compare, say, hashes of the files, you'd be able to know which one was there.
Yeah.
Does it also copy the JVM into
Yes.
that as well?
Yes.
So if you needed to upgrade for a bug fix for the JVM, you'd then need to go and relink the application?
Yes. Yeah, that would be the idea, because it basically creates a whole runtime unit. And then, yeah, if you wanted to upgrade the JVM, you'd have to create a new runtime unit and deploy that. Yeah.
Ideal for Docker then.
Yeah.
Hi. Just thinking about context sharing between modules. With OSGI, it seems like each module gets its own class loader, and that's how the partitioning works. Is it similar with Jigsaw? And are there, if you wanted modules to share some sort of context, would they have to do, like we heard earlier, using a service and a registry to?
Yes, because it will have a separate class loader. That's the way of isolating the individual modules and then creating those barriers between them. So yes, you would need some kind of, as you say, some way of communicating between them.
Right. Just one more question. Is it possible to reload at runtime with Jigsaw?
No, as far as I know.
So you couldn't bring one module down and replace it without restarting the JVM, I suppose?
No, because it's not dynamic, which is what Alex was saying about OSGI. It is static.
Right.
Any more questions for Simon?
Oh, I'm all right.
How difficult do you think Jigsaw's going to be for actual developers? Do you think there's going to be a sort of a bit like NIO and various other things? It's going to be a version 2 or how sort of kinks get worked out as we discovered?
So how applicable is it to developers in terms of using Jigsaw? I think it's very applicable because I think that what you're going to have to do is when you're developing code for JDK 9, you're going to have to think about what the dependencies are that you have on the runtime. Obviously, it has the ability to kind of allow you to do things gradually, so you don't have to kind of rewrite all your code straight away into using modules. But I think the developers are definitely going to need to have a close look at it. So yeah, I mean, as you said with NIO, it was a sort of gradual adoption. I think it'll be the same thing with JDK 9 and Jigsaw. It will be a gradual adoption because people will use, okay, there's modularity in the runtime, and then they'll start modularizing the library code and then modularizing the applications on top of that.
Okay, a final question from anyone? Looks like a no.
Okay.
Thanks, Simon.
Thank you.
Excellent talk.